Okay, today we're going to be talking about graphing linear inequalities. So first of all, linear inequality is similar to a linear equation but uses an inequality symbol. So what I mean by that is, if you remember a linear equation, let me write a linear equation here in standard form. 2x plus 7y equals 8. This would be a linear equation in standard form. Now if we were talking about linear inequalities, it would look similar. If we were writing a linear inequality in standard form, it'd still be 2x plus 7y, but instead of an equal sign, there'd be an inequality symbol. So it might be less than or equal to 8, greater than or equal to 8, just less than 8, or greater than 8. Now the difference when we're graphing a linear equality is that we're going to have to shade a region. And if we talk about inequalities and inequalities in one variable, like we worked on a couple months ago, let me just put this down first. X equals 3. So if we were to plot x equals 3 in just a horizontal number line, all you would do is find 3 and put a dot on 3, and that would be your only answer. But if you remember with inequalities, when we were only dealing with one variable, it was if x was greater than or equal to 3, that means your answer can be 3, so you'd put a solid dot on 3, but it could also be anything above 3. That is where the inequality symbol comes into play. That's what that means. X could be equal to 3 or bigger than 3. So with two variables, it's going to be very similar. We're also going to have to shade a particular area of our graph, and we'll talk about those steps in just one moment. So here are the steps, and I know it's going to be a lot of writing, so feel free to pause the video. But your first step is to put the inequality in slope-intercept form, just like you would if this was an equation and not an inequality. So put the inequality in slope-intercept form. Now remember, this is an inequality, so be sure to flip the inequality symbol if you multiply or divide by a negative number. Now here's the difference. If you remembered from a few months ago and from your middle school days, when you were graphing inequalities on a number line that just contained one variable, like x is less than 0, if it was less than, you would not put a solid dot on 0 because you weren't including 0. You'd put an open dot, right? So these next two steps are similar, okay? If we have a less than or a greater than symbol, that means we're not actually including the line. So we are going to use a dashed or dotted line. Use a dashed line for less than or greater than symbols. Now if this was x is less than or equal to 0, then you would put a solid circle on 0 and you would shade to the left. So if it's less than or equal to or greater than or equal to, you would use a solid line. As with inequalities in one variable, we are going to have to shade. And when we have inequalities that have two variables, so shade above the line for greater than or equal to symbols, shade below the line for less than or equal to symbols. So here we have an inequality in standard form. So first thing you're going to want to do is change it to slope-intercept form. And the way you would do that is you would first need to subtract by 2x. And hopefully by now you are pretty comfortable with manipulating and changing equations and inequalities to slope-intercept form. Okay, then your last step would be to divide everything by -3. Now, because this is an inequality and because we're dividing both sides of the inequality by a negative, we would have to flip the sign. So that would be y is greater than positive 2/3 x minus 5. Now, you're going to graph this in a similar fashion than, or at least in the beginning, you're going to graph it in a similar way as you would graph a linear equation. So your y-intercept is -5, which is down here. Then you're going to go up 2 and to the right 3. And pretty much that's all I could do. All right. Now, here's where it's going to be different. Because this is a greater than symbol, we aren't going to use a solid line. We're going to use a dotted or dashed line that looks like this, and that tells us that we're not actually including the line in our solution set. Now this is a greater than symbol, so we would shade above the line, and that means anything that's above this line could be a solution. So this green ordered pair right here, would this be a solution to this inequality? No, it is not in the shaded region, therefore it is not a solution. this green dot right here that's right on the line, would it be a solution? No, it's right on the line and we are not including the line. That's why it's dashed. This green dot right here, would this be a solution? Yes, it is in the shaded area, therefore it would be a solution. Okay, let's do this one next, but I want you to change this to, instead of less than, let's change it to less than or equal to. That way we have a solid line instead of a dashed line. And I want you to have one example on your notes with a solid line. So we would change this to slope-intercept form first, which we would have to subtract both sides by x. This would be negative 4y is less than or equal to negative x plus 8. Then we would divide both sides by negative 4. And because this is an inequality, and because we're dividing both sides by negative, we would have to flip the inequality symbol. This would be positive 1/4 x, and then that would be minus 2. So I'll do this line in blue. Your y-intercept is going to be negative 2, which is here, and your slope is rise 1, run 4. Rise 1, run 4. Or we could go down 1 to the left 4. Go down 1 and to the left 4. Now what kind of line we're going to use this time? Is it going to be a dashed line or a solid line? Well, because this is greater than or equal to, that means we are going to be using a solid line because we are going to be able to include the line in our solution set. So it would be a solid line. Now we have to shade. So we're going to shade above or below this line. What's greater than or equal to, which would mean that we would be shading above this line. That means our solution can be anything above this line or anything that's actually on the line. So let me get my green out again. If I put an ordered pair right here, would that be a solution? No. If I put an ordered pair right here, which would be 4, negative 1, would 4, negative 1 be a solution? No, it would not. I'm sorry. Yes, it would. It's right on the line, and in this case, we can include the values on the line. So yes, that would be a solution. Would 0, 0 be a solution? Yes, it would also be a solution. Would 0, negative 4 be a solution? No, that would not be a solution. All right, so hopefully you're becoming a little bit more familiar with this. Okay, let's do another one. Y is less than or equal to negative 4. So remember, this was y is equal to negative 4 when we were graphing lines on a coordinate plane. Anytime it was y equals a number, it meant we were going to be dealing with a horizontal line. And because this is y equals negative 4, it would have been a horizontal line at negative 4. Whereas if it would have been x equals negative 4, then it would have been a vertical line on negative 4. So with inequalities, it's very similar. So y is less than or equal to negative 4 would mean that we are going to have a horizontal line on negative 4. Because it's less than or equal to, it would mean that we would have a solid line on negative 4 and not a dashed line. And it's less than, which would mean that we would shade below. Okay, now let's do one more. What about if this was x was greater than 5? Okay, x is greater than 5 would mean that we would have a vertical line right on 5. And because it's greater than, the vertical line is going to be dashed, which means we are not including it in our solution set. Now, greater than 5. You can't really go up and down with a vertical line, but obviously if we're looking at the x-axis, the numbers that are bigger are going to be the ones to the right of this vertical line. That's where all of our bigger numbers are. So you would shade all the numbers to the right if you were giving a vertical line. Okay, and that would be your solution set. It would be anything to the right of that line, not including the line though, because it's greater than and not greater than or equal to. So tomorrow we'll do some word problems, and we'll do a few more problems on graphing inequalities. Hopefully this video helped. Make sure you took good notes. See you tomorrow.